So let's go ahead and start with that one. So let me just flash a couple of, I have 9 slides, no more than that, and then I'll jump directly into the blueprints. So this chapter, very easy. And can I get you guys to, Jamie, my friend, can I get you guys to understand when you are answering these questions, if you get frustrated trying to find things, the whole idea is to get you to maneuver yourself into other sheets that non-electrical. It is frustrated to deal with the non-electrical stuff. Should be like mechanical, trying to find the elevation and so forth. It really is. It's a lot of work to try to coordinate between different disciplines. A lot of us barely can handle the electrical field itself, let alone coordination. Coordination between different disciplines, Jeff, is a higher level thinking. You're going to first fully understand your stuff, and then you have to go coordinate between your conduits and their walls or equipment. So be aware of that one. Um, so let me go, guys, a little bit and just go over these. This chapter talks about reading and interpreting electrical symbols. The only reason why I want to do it because I want to show you just the electrical symbols that they're using here. You guys went higher than this, Darren, in this class. We designed electrical system. But before you design, I hope you can read and understand it, right? So I found it sometimes easier to design things than read and understand what other people have designed. So read and interpret and design. That will get you guys to help you do the identify electrical installation for the drugstore. This is a multi-tenant commercial building. So you guys, when I do design, Jeff, I always say, if anybody asks you if you're an electrical designer, you would say, yes, I'm an electrical designer, but in the following fields. So if you have never done, you guys are going to do with me 3 projects, right? You did residential, so multi-family dwelling. You should be able to do a multi-family dwelling right now after we didn't care. We're going to do a commercial building. You should be able to do a commercial building. We're going to do industrial building. If anybody asks you, have you done a hospital? We don't do hospitals. So, but the information that we give you, I would say it's good enough up to 70% of what you need to do a hospital. You still need to go research another 30%. Very, very important to be aware of that. This project will help you get closer to that 30% that you're missing when it comes to a commercial building, different tenants, not just owned by one person. So you get into metering equipments and a bunch of other things like we did in the residential. So we have a drug store, we have a bakery. So they have different system. I'm going to show you guys this one in detail. So I'm going to skip over this because I'm coming back to it. I'll talk about the only thing I want to tell you guys right in front of you. We're going to have the sheets, the architectural sheets in a second, as well as the mechanical sheet that shows everything else. This is just talk about it. And neutral conductor, neutral point, and ungrounded conductor. I just want to emphasize in the electrical industry, we have these are your phases, phase A, phase B, and phase C. This is the neutral point, number 1. Number 2, this will be my, no, sorry, number 2 is right here. This will be my neutral, right? And then you have the equipment grounded conductor, which is number 3. And I hope when we did the calculation, Adam, my friend, I cannot drive it enough that when you deal with a system, you are dealing with basically it's a 5 conductor system. When you deal with an industrial commercial system, it's a 5 conductor system, right? Can you guys see that? We have 3 here for the 3 phase. We have most likely 1 here, right? That's 4, and we have 1 here. That's 5. It's 5 conductor system, right? 4 conductor plus the ground. 4 conductor plus the ground. So being aware of that. So that's basically what this talks about. The neutral point in the residential, guys, you'll see them. Here's this point that they ground. It's called the neutral point right here. This is in the residential. In a commercial, when you have a 3-phase system, this is called the neutral point. Can you guys see that? That little point here called the neutral point. Who cares? Because now I can pull the neutral conductor from a neutral point. Really, that's the most important thing. Pulling a neutral conductor from a neutral point. That's it. You cannot have a neutral unless you have a neutral point. If you don't have a neutral point, you don't have neutral. And also the code calls the neutral. What does the code call the neutral? Grounded conductor. Intentionally grounded conductor. So these are the things I want to mention here. Special feature for drugstore wiring, low voltage. In the drugstore, I'll show you here, they use low voltage remote control system, lighting system. low voltage remote control lighting system. Kerry, my friend, this is exactly what you guys are going to be doing with your friend chat. We're going to be doing low voltage control system, meaning we're going to have a relay panel and a low voltage switches. They can turn on and off the relays, which in turn turn on and off a contactor that turns the light on and off. Why would anybody go to that extent to do a lighting system? Because if you can capture the lighting as low voltage system, you can interface it with your computer. Then now you can program it to do whatever you want to do. I can't program that dumb switch here. Can you? What can you program that dumb switch? Nothing. But if I have a low voltage switch here, interface with a relay, I can program that relay to turn on and off at certain time of the day. Master switches, which you guys are coming. This is opinion. When you do this, I know a lot of people who do that. You need the request manufacturer literature all the time when you install them. Not really rocket science. In the drugstore, they also have different type of illumination system to make things look nice and cool. So that's what they're doing here. We have a bakery, guys, and we'll talk about the different type of lights, conventional control system switches that they're using in the bakery. So what I'm gonna all these tenants I'm gonna show you guys in the blueprints. They're really cool because they use different lighting and different power system for all these tenants. You're gonna look at the one line diagram and like it, I'm sure. Okay, so let me just go directly, and this is what this chapter is really talks about the specification. I wanted to show you before I move on, just because I don't think the systems are here. So give me 1 second here to walk you. This is where I'm going to be walking you guys through these in a second. But before I do that, allow me, my friends, to get you into PDF here. Oops, not this one, Chad. Okay, library. There you go. Library. I'm gonna go just the blue. Okay, we'll talk about this one in a second. Here's the symbols that they use, because the symbols are not in the blueprints. We have a list of symbols that I want you guys to use. You already loaded the symbols in our Revit MVP, but I want you guys, here's Kerry, if you're confused about something and it's not in a symbol list and you need an example, here's an example. For example, conduit concealed in finished areas, exposed in unfinished areas. This is a symbol they can use for it. Conduit concealed in or under a floor. That's where we use these symbols. Non-rigid conduit. Again, symbols, guys, are, for the most part, I would say 80% of all the symbols that we use for the electric industry are the same. There's a 20% that's different from one to another. So who cares? Use these, guys, if you need hints. So look at that. If you have this line, this is T. T in the middle of it, telephone. Underground raceway for power, PT, for power and telecommunication, PT. Underground signal circuit. So these are the symbols that they use in this project. Should I use these symbols? No. Is it a good idea to, if I am in a situation and I need to bring the underground, for example? We didn't use this one last time. Remember, we labeled them with, but if you are to use this symbol, then you have to basically put it in your symbol list. Okay. So that's why I want to show you a few things just to be aware of. For example, another conduit here. Raceways indicator symbol. Conduit stub terminated with bushing or cab if underground. This is conduit turning up. This is conduit turning down, the symbols that they use. These becomes very handy when you read the blueprints in this project, because if they ask you where's the conduit that's going up, you'll be looking at some symbol that looks like this. Going down, symbol that looks like this, based on this project. Can I have thumbs up, Chad? We understand? Cool. And indicate trade size, conduit with 4 conductors. This is how they indicate their trade size and so forth. I'm going to go all the way to the circuit. Home runs to the panel. Number of errors indicate number of circuits. Number of errors, number of circuit. Example, we have L211, circuit 1 and 3. Circuit, in this case, that will be circuit 1 and 3, right to the top. Can you guys see that? So we have a circuit 1 and circuit 3. L211, that's panel 211, and 13, exactly like we did. Is that similar to what we did in last project and what we're going to be doing in this project, as a matter of fact? We did them at the bottom, right? We slashed them, but there's so many ways of guys doing that thing. Here's 2 circuits. I can tell two circuits, and I can tell here's my hot, my neutral, and my ground. Can you see that? Hot, neutral, ground. Fuses, direct connection to equipment. Branch circuit full slashes indicate ungrounded conductor. Here's where it tells you the full slash. In this case, full slashes indicate ungrounded conductor hot or switch leg. Circuit conductor half slashes indicate grounded conductor. That's actually the opposite of what we did in another project. But as long as they identify it, neutral circuit, not hashed, indicate one hot, one neutral. So it gives you all the terminology that you can use. And the other thing for the symbols, guys, here's luminaires that they use symbols for luminaire surface mounted. We have our own list, guys, and our own stuff, but use this as a FYI only. Can I have you guys get you to use this one as an FYI only for all the fixtures that we're going to be using. Here's more of outlet receptacles and symbols. Look at the floor outlet. Here's the symbol that we're going to use for floor outlet, duplex receptacle. This is duplex convener receptacle on emergency standby circuit, specialized. This is, they're putting this one in the emergency. So if you're reading something in the blueprint and you don't understand what it means, you're going to refer to where? These specification. Okay? And I don't want to make it more overwhelming here. Multi-out assembly. Look what they specify multi-out assembly. When we use it in an industrial project, we use a different symbol, guys. It doesn't matter. Can I get you to understand? It doesn't matter what symbol you use as long as you define it. Can I have thumbs up, Chad? As long as we define it, for the most part, you can use any symbol. Okay, so these are a few symbols that I wanted to indicate. A typical outlet notation, a switched outlet A indicates switch control. So these are, as you read through the blueprints, if you get stuck with any one of these, you have to refer to this list of abbreviation. Cool? List of abbreviation. Here's your switches that you use. This is my single pole switch, double pole switch, three-way switch, four-way switches, different indication for four-way switches. Where does it say elite? Here's my favorite, or you should be your favorite. SLV. Anybody can know what SLV is? Low voltage switch. That's your 24 volt switch that's going to be interfacing with the relays. This is the one that we're going to be using, Jeff, in our commercial project. So please pay attention to this particular one because we're going to be using it a lot. LM, this is low voltage master switch. You flip that boy and it shuts down the whole lighting system in the whole building or in the whole store in this case. So can I get you guys to understand that as you move through the blueprints, these blueprints, if you're stuck with a symbol that you don't know, where are you going to go? To this symbol list. Okay? And you can spend a lot of time, guys, going through this symbol list. We're just indicating it here. Okay, motorized and HVAC equipment. Look at this. I have a disconnect with XX means indicates the amp bridge of that disconnect size indicate on the drawing like 50, 60 amp disconnect, right? The frame indicate frame size, indicate fuse size. If you have it this way, then that will be AF, for example, that will be 60 AF over 50 AT. So that will be a 60 disconnect, 50 amp fuse. I've seen it done differently, but this is one way of doing it, frame size and no, I'm AT, the fuse here, AF. And for circuit breakers, that will be the frame size and the trip size. Tomorrow, my friend Todd, guys, will go through a few of trip size versus frame size. NEMA, magnetic starters. So I'm not going to go over through all of them, but I want you guys to assure me that you look at these as you walk through the blueprints. Can I have thumbs up that you guys walk through them? And please, if I was in your shoes, guys, and I'm going to be a designer, I will look at them. Your job is to look at them right now. You're not going to memorize all of them. You're not. You will never be able to, but at least get familiarized a little bit, read through them. And remember, every time you get stuck with any symbol, where are you going to come? Right in here for this particular project. Okay, then we go into motorized HVAC. Here's the motor. 3 indicates the horsepower, so that will be 3 horsepower. Motorized dampers. We'll talk about dampers as we move on. Baseboard and a bunch of other symbols that they use. Fan, panel fan, water heater. Panels, my favorite. Power distribution system. Lighting or power panel recessed. Can you guys see that? Lighting or power panel surface mounted. Distribution panel. lighting or power panel on the normal and the generator. So look how they use this symbol to indicate generator. This is an emergency panel. Can you guys see that? So when you look at the blueprints, make sure you're aware of that. Otherwise, you're going to get confused. Distribution panel on the normal, not generator. MCC, dry type transformer, a transformer pad, current transformers, generator. Can you guys see the generator? Meter single, meter socket. Can you guys see that? And transfer switch. All these are the symbols that they use for this project. Why it's important, Zach, to spend time with this? You guys are designers. The more ideas you get, the better you will be. The better you will be, period. Done. Because I can't, with the time that you guys will do with me, we can't design a lot of other stuff. So you can use this as supplement to the design that we do. Underground, on the site, UF, UT for telephone. I would use these ones, guys, when you underground fire and so forth. These are manholes, handholds, and so forth. And last but not least, I believe, the neutral point that we talked about, this is not symbols. Remember, there's a really nice, and I know you guys are familiar with this system. You're familiar with this system. This is center tap delta. These two are not commonly used. This is corner grounded delta, not neutral. And this is zigzag neutral point. So the only thing for the neutral, I will emphasize, you're going to, between these two, you are probably up to 90% of the system that we use, single and three phase. This one, probably 10% of the time you're going to see this, and the rest of them, these two. This is just 120 only, there is no 240. This is not a neutral, can you guys see it? I'll talk about a corner grounded delta. Corner grounded delta, I'll talk about it when the commercial goes. Why do we corner grounded? What's grounded, ungrounded? We'll talk about this one. The most important things I want to make sure before I leave that everybody understand this 120 volt 240 system, and this is my 208/120 volt or 480/277. Can I get you guys to understand these? Everybody understand that's a system? The rest of them come as we go to the commercial project. Okay. Couple of other symbols that they use, guys, for the emergency light and so forth. We use a lot of these last time. Okay, so that's basically what I'm going to show from here, if you don't mind me. And next, I'm going to take you guys to the blueprints, and let's go look at the blueprints. Okay, here's what I'm going to do. Here's all the blueprints that you guys have. So please grab your blueprints, have them handy. And so what I'm going to do, guys, you have how many blueprints? We have 6 A's. Everybody knows what A stands for? Architectural. And how many E's? 4. Everybody can see it, guys. I have 10. You should have 10 front and back, double-sided blueprints in the front of you. Can I have thumbs up, Chad? We got him? Cool. Now, I'm going to start from the end. Why am I going to start from the end? Because if I can get you stuck, guys, in the architecture, we're not going to get out of that. So let's start from the end. What are we doing in this project? We're electrical. So let's go look at the electrical. So I'm going to start from the end. Can you guys go all the way to E4? That's the end. Everybody can see that? Double click on E4. When you go to E4, here's your project. I want you guys to zoom to understand what this project is. I always start with the riser. If you don't start with the riser, you're doomed. Can I get you guys to focus on the riser? Can I have thumbs up, Chad? Focus on the riser. Okay, so how is this? This is what this project is all about. I'm bringing power here to a gutter, right? And then I'm taking this power and feeding multiple loads. Can you guys see that? Multiple loads through meters. And I'm going to just focus on these as we go through the loads that we're doing. Multiple loads, and also an owner equipment load right in here. Can I get you guys to focus on that one? So I have a building that has how many tenants? 1, 2, 3, 4, 5 tenants in this building. 5 tenants, and each one of them is having a power of his or her own, and I have a gutter here Can you guys see the way they did it? They brought the service into a gutter, a box, and they fit from this gutter a disconnect fuse. A fuse disconnect like this with a meter right underneath it. The cheapest way of feeding a commercial building, you're going to see this one there for strip malls. Very common for strip malls. Because multiple tenants, you come to a gutter, from the gutter, everybody knows what a gutter, box with the cables in it. And from there, if this is big, this could be a gutter here, up to 30 feet. You bring the cables in, you tap from the cables, and you go to the meter and disconnect, Can I have thumbs up, Chad? We fully understand that? Cool. So that's what this system is. How many tenants do we have? We have, can anybody read this one, Beauty? Read that one. Salon. I always say it wrong, that's why I want you. Beauty salon, bakery, insurance, and real estate, and drugstore. These are the 5 tenants in this building, okay? The owner of the building, though, have to put the hallways, because the hallways are not owned by any of these tenants. The hallways and certain things on the house panel. So they have another panel here that's called owner. This is your house panel. That feeds the common spaces and so forth. Can I have everybody understand? That's what the system is. Okay. So we brought a service, 28120. We fit them. Can everybody understand the meters? We have meter for each one of them, because each tenant is going to be paying separately for this service. We have meters, and after the meter, I want everybody to understand where we can have a disconnect. Can you guys see the disconnect here? The fuse disconnect for each one of tenants. Why? This is your service entrance disconnect means. Service entrance disconnect means. With a fuse, of course, you have to have a fuse. And then inside the building, we have the panels. Can you guys see that? The panels. So if you start with the end, here's the panels. So how many panels do I have? 5 for the tenants and 1 for the what? The house, the owner. Okay? And there's the elevator equipment and elevator control. These are just control for the elevator. But how many panels do I have? 5 panels. Do you see how starting from the end get you to understand what the system is? Does that make sense?
Yeah, what?
Go ahead.
Were you just drawing that as an example on the 208 panel, that disconnect? Is that on all of them? Or
This is 200, 150. This is, I can't read.
The disconnect that you drew?
The owner?
The disconnect right there?
Yeah.
Is that on all of them?
Yes.
Okay, that's what I thought.
Absolutely. Each one of them, I don't know, right here. Do you see them after? Each one of them will have, yep.
Is that that little switch thing that's kind of...
Yep, the switch and the fuse. Absolutely. Each one of them has a disconnect, fuse disconnect. That's a service entrance disconnect. Can you guys see how the system is put together? Everything black is standalone system. And then the meter is separate enclosure for the meter. Here's a meter, right? So how many enclosure? I have 1 enclosure for the gutter, 1 enclosure for the meter, 1 for the fuse disconnect, and 1 for the panel, for every system. Can you guys see how the system is put together? Can I have thumbs up, Kerry, my friend? You fully understand? And Andrew? Okay, so that's why it's nice starting from the end. And then they have a generator, but the generator is only, can you guys see the gen is sitting here? The gen is only feeding the owner equipment. The owner panel is the hallways, the elevator. I think they're having elevator equipment, elevator control, a bunch of owner, very important loads. They back them up. So especially the hallways, because emergency light, guys, they want the light to come on. Okay? And I'm not going to read through this, but this is all of them are numbered. So exactly what you're going to be doing with me. They're all numbered, guys, and they have the conduits, the size, and everything else that's going to be feeding all these systems. Isn't that cool to have a standalone system size in the front of you? Can you have thumbs up, Chad? We understand that system. Okay, so I'm not going to read through the conduit. Maybe I should do the service. Can you guys see the service? It says, if you zoom in the service, it says, let me delete this one or move it away here. Okay, it has service, 3 thread size, 1.5 inch PVC. We don't care about the metric designator, with 350 kcm and 1 1/0. What did Chad tell you about that one? Where's the insulation size? So they're paralleling. Can you guys see what they're doing? They're having a conduit of 3.5. How many of them? 3. So the way I would write this, I would say 3 3.5 inch PVC. Didn't see any designation, most likely 80. And how many conductors? 3 conductors, number 350 kcm and THHW, and 1 conductor number 1 at EWG THHW. Does that make sense? That's exactly what you guys are going to be doing with me. They wrote them slightly different, but the concept is there. Can you have thumbs up, Chad? We fully understand how this is. Okay, so that's basically what the system is. Start from the end in mind. Okay, so that's what I want to show you. So 5 tenants, remember, 5 tenants, each has its own meter and disconnect, and we have the owner, and we have the owner here is feeding, and look at the size. Now I want to zoom at sizes. This guy have 400, okay, now who's going to tell me what's the first number, what's the second number? The first number, it's a fuse disconnect. So one size for the disconnect, one for the fuse. Remember how we said they're different? The disconnect and the fuse's size are different. So let me show here. So this is actually a 400 amp disconnect, but what's the fuse? 300. So when you size your cable, do you size based on the 400 or the 300? 300. We size based on the fuse. Okay. So I want to just emphasize that one. 1 amp here, for example. This is another. I have a 200 amp disconnect because I don't have 100. If I have 150 disconnect, what do you think? Why do you think they did it this way? Because there's no 150 amp. They don't make them. So if you need a 150 amp fuse, what do you need? You need to stick it into 200 amp disconnect. Can I have thumbs up, Chad? We understand. You guys are.
Yeah, Chad.
Yes, sir.
All the meters are kind of like on the lines here, except
yes.
That number 3 up there kind of has that little thing on the end of it. It's offset. 3, top, middle. Yeah.
This one.
Yeah. What is that symbol?
Meter. Okay. Very good point. Very good point. I want you to look at now. Very good point. Very good point. These are inline meter where you bring the power right through the meter. These are meters with CTs. Up to 200 amp, guys. You can buy a meter that can handle 200 amp. And even 300 amp, I think that some of them are 300 here. If you go 400 and higher, you can't bring the 400 amp directly through the meter. So what they do is they take a CT, a sensor, and then they feed a meter. So this will be the 400 amp here will be seen as 5 amps. So it's a way, because if you put all the 400 amp through the meter, you burn it.
CT is
a current transformers. Yeah, they use a current transformer, guys, that sit the 400 amp down to 5 amps, and proportionally, if this goes like 200, this becomes 2.5. So you can measure it. You can measure it. This is typical on 400 amps and higher. Anything 400 amps and higher, we don't have a meter for it. Good, very good point. Very good observation. The rest of them, can you guys see it? This is up to 200. I don't think they have anything higher than 200 amp here, do they? All the 200 amp are up to 200 amp. They're right through it. Can you guys see how it goes right through it? Everybody can see that? Okay, very good point. Thank you for mentioning that one. Okay, any question, guys? I want to bring the bonding. Can you see the transformers bonded and grounded here? Here's where they tell you all conductor copper with THHN/THWN insulation. So they put a note here instead of writing it like I do right next to it. So they are double insulated. So a lot of this is very common, guys. Instead of having an insulation for in and insulation for out, the manufacturer smarter than Chad say, how about if you boost THHN/THWN? So if you're outside, THWN. If you're inside, THHN. Does it make sense? One insulation for one size conductor. Cheaper way, better way of doing it. Okay. Any question, guys, about the riser before I move into something different in this area? Any question about the riser? Because the most important thing, if you guys understand that one, you'll understand. Can you see the auto transfer switch? Can you see that I have only auto transfer switch and it's only feeding the owner equipment? Only, not everything else. Can you guys see number 8 here? They have the main bonding jumper. Can you guys see number 8 here? They have the main bonding jumper. So they take the neutral in the gutter and they grounded the neutral to the ground. That's what you guys were doing with me on Friday when we sized the grounding electrode conductor and the main bonding jumper. That's exactly what they're doing here. Okay. Any comments? Any questions for Chad? All right, so have I said the 5 tenants and the owner equipment? Now, the rest of them is piece of this isn't 4, piece of cake. Let me take you to this corner here and walk you quick through this. This is a list. This is the gutter. Can you guys see that? This is the gutter and the service. The switches. Remember, circuit number 1 was 200 switch, 200 fuse, and service entrance conductor feeder. It's 2-aught plus 2, the neutral. And I have raceway size 2 and 2 raceways, and the size was 2.5. And and so these are, yeah, these are for the raceway. Okay, so this is up to here. So I have a conductor and a raceway. If you go to the bakery, I have circuit number 2 feeding into the bakery. It's a 300 amp fuse, a 400 amp switch, and service entrance conductors, 304. 4 conductors, basically. It's not service entrance. These are feeder, really. Cool? Oh, they are, as a matter of fact, service, because they're coming into a disconnect. They are service entrance conductors. Okay, so this is list 1 through 6. Remember that 1 through 6 disconnect? It lists the feeders that feed these disconnect. It's not a panel schedule, so to speak. It's a disconnect schedule. Okay, so when you say 1 here, if you guys go back to the way it's numbered here, where's 1? Well, let's talk about 3, because Brian talked about 3. Here's 3 here. So if I go up here, where's my 3? Here's my 3. That's the insurance company. Circuit 3, no. Where's 3 is the bakery. Okay, 300, 300. Okay. Why am I not getting?
Because you have don't count 1. That's the main feeder.
I see. I see. I see. I see. 1, 3. Okay. 1, 2, 3. Okay. So 1 would be the feeder that feeds all of them. That will be for circuit number 1. That one here? Oh, no, I'm sorry. Here, they're using these numbers here. Okay. 1, 2, 3. Okay, gotcha. There's these numbers at the bottom. Okay. Okay, not the disconnect numbers. Okay, so these are basically the equipment. Any question, guys, about these? How many circuits? By the way, when they say the circuit number 1, everybody understand that this is a 3-phase circuit? They call it circuit number 1, right? Everybody understand that this is actually, when you size it, it's a fuse and a disconnect, a fuse and a disconnect, and a fuse and a disconnect. This is what circuit number 1 is. 3-phase circuit. And the same thing for 3 and 5 and 2, 4, and 6. These are 3-phase circuits. Cool? Okay. This is really, that's it. If you understand this one, the rest is history. So what I'm going to do, guys, then here's the panel schedule. I'm just going to flash the panel schedule right here. There's the panel schedule in the bakery. It's flush, 28123 phase 4 wire, wall near back room. It's a 400 amp. It's the interrupting rating is 240 kilo interrupting rating, and it's fit from the main. Can you guys see that? That's typical what you did with me for all the panels. And how many schedules do I have here, and why? I have 1, 2, 3, 4, 5, 6 panels. What do you think that panel would be? The real estate. This is the real estate and all the information about it. I'm going to go to this one, to the owner. Is this the owner? Yeah. Here's the owner panel. The owner is a 200 amp panel. Look what it's feeding, guys. It's feeding basement and the outdoor lights, receptacles, heaters in the toilets, base heater, women toilet, sump pump, elevator circuits, lighting in the first and second, the telephone, a bunch of heaters, base heaters in the men's bathroom, and water heaters, and a couple of spares and fire alarm system. Can you guys see what this is coming? The owner panel is feeding. Everybody see that? Okay, so that's, I'm not going to look at all of them, guys. We'll be looking at them, basically, you guys will be looking at them as we go. Any question about this? That's what this project is all about. That's what this project is all about. Can I have thumbs up, Chad? We fully understand that the project is. Okay, So start from the end. This is the end. This is what you're designing, a two-story building with a basement for 5 tenants and an owner panel. Would that give you guys the big picture? Now let's zoom in slightly and go into the first one. Okay, now let's look at what E3 is. Are you guys at E3? Second floor electrical plan. Second floor electrical plan. Now remember, Andrew, how many tenants do I have? 5. So remember, the building is divided between all those tenants. Each one of them has its own service and its own meter and its own electrical power distribution panel. Cool? Just keep this in the back of my mind. Okay, let's look at the real estate office. Here's the real estate office. I'm not going to look at the power, guys, and lighting. Can you guys see all the receptacles? I'm not going to look at the layout of the receptacles and all that stuff. There are chapters that talks about each one of them. I want to remind you guys, so here's my real estate office in here. Here's the branch circuit for the real estate office. The beauty salon is here. Here's the panel for those guys. Can you guys see? Here's the lighting system for it. Bunch of receptacles. A bunch of lights, emergency lights. Can you guys see in the hallways emergency lights? So that's basically what the building is. In the second floor, we have the insurance office, insurance rooms. Can you guys see real estate office and the beauty salon? Right? That's in the second floor with their lighting system and horn strobe and low voltage system and so forth. I don't want to focus on reading the whole thing. I just want to give you the big picture now. Everybody can see that? Can you guys identify where the baseboard, here's the panels. Now, baseboard panels, the panels that they have here. So that's my second floor. Real estate, beauty salon, and insurance. Okay, go back one level. This is the first floor. In the first floor, they have the bakery store and the bakery. Can you guys see that? All of it with the panels for the bakery right here. They have they have the insurance, the drugstore right here, right? And the drugstore has the low voltage system. And I'm not going to walk you guys right now. See LVP. This is the low voltage panel for the lighting system in the drugstore. I'll be walking you guys through this one as we get close to the lighting voltage system and get into details. I want you to look at just the big picture now. Here's the panel board. All the lights, all the switches. I want to emphasize one thing here. If you zoom in here, this is RCA. This is the low voltage switch A that's going to switch all the A fixtures. Can you guys see that? Here, right in here. Okay, so that's all your in the first floor. Let's go back into first the basement. In the basement, the drugstore goes all the way to the basement too. And down here, the bakery store and the beauty salon is also goes down to the basement here. So some of them extend to in a two-story building. And here's the hallways and the stairways in between them and so forth. Here's the main panel, auto transfer switch. Look at where the auto transfer switch, main panel, that's the owner panel. So any comments, any questions? Again, I don't want to get into the detail of the lights and all the stuff. It will come, guys, as we go. But give you an idea, everybody can see the big picture. 3-story buildings shared between 5 tenants. Some of them go 2 stories, some stay on one level. And they have the light and the power and the low voltage in one blueprint. Unlike we did, Aaron, in the commercial project, in residential, they put them all in one level. Okay, any question, guys, about the E's, the 4 E's? Can I have thumbs up, Chad? We fully kind of understand how the system. As we move forward, please, Zach, just read through them, guys. Get good ideas how to design systems. Okay, so that's basically the bread and the butter. Now let me go take you to the architectural. And the architectural, I'm going to go for architectural all the way to E1. Oops, E1. Okay, I'm sorry, A1. Can you guys go A1? Start from the beginning. Architectural, guys, will give you the dimension, give you the thickness of the walls, give you the doors, the windows. Why it's important? Because when you do estimating and you want to cut right through a wall or ceiling, it's really cool. Not cool. It's very important to know what type of a wall. Is it concrete cast wall? Is it sheetrock wall? So very, very important to get information. So Brian, my friend, when you walk through this and you get frustrated, you are absolutely right. It is frustrating because we don't use this day in, day out, especially the architectural stuff. So here's my question for Aaron. If you get the 4 sheets, E1 through E4, get all of them, understand them fully, you really got the hang of what we're trying to do here. I mean, the rest of it is great. Great to know. Okay, so to give you guys the dimension, they ask you a lot about the dimension. Here's all the dimensions for the place. Here's the bakery store. A lot of information you can find in the structural right here. Conduits up and so forth. So here's the drugstore. Basically all the information that you need. Architectural information here. I'm going to jump into the second floor. Same thing. Dimensions. You know, if you want to measure walls, stores to scale and all the stuff. And if you go to the third one, E3, exactly the same. A lot of dimension, a lot of stuff that you need to know. Cool. So if they ask you anything architectural, you're going to be referring to A1 through A3, A6. Okay, so these are what we call them plan view, architectural plan view. Okay, and I ran through them, guys, because you read through them. Look at the dimension. Look at the dimension of the wall here. It can give you even zoom here. It can give you a foot wall. So a lot of the facade that you're going to be using, you name it. The window. Look at that. You can get you the window is 5 foot 10 inches. A lot of details, information about the actual structure. Cool. Can I trust that you guys are not going to sleep tonight until you get that boy under control? Okay, let's go to E4. E4 is elevation. A4, thank you. A4 is elevation. The east elevation is going to look like this. Can you guys see? It's a nice view of the second floor and first floor. Main entrance to the building. Now this is where it gives you the height. When we're doing Revit, this will be shown, guys, directly in Revit. Look at that. That will give you the height of the basement, the height of the first floor, and the height of the second floor. That's what this is very important for, right? The height. Why would it be important for me to put the height? I might be putting lights at the top of the ceiling, security lights and so forth. Can somebody give me a thumbs up, chat? We know the elevation give you the height of the third dimension. Okay, so that's north. Let's site. Oh yeah, here's the site. This is what give you how the building is located. Parking lot, right of way 10. Can you guys see where's the building? The building is actually 43 by 60 feet. Area drainage, blah, blah, blah. All this information, the site. I have a site. I give you guys 2 sites by now, right? The site is very important for parking lot lights and bringing power and low voltage to the building. That's all what you want to worry about. So that's my site. They put it here. Then they have another elevation. This is the west elevation. From the west, this is my favorite. This is how your service is going to look like. Can you guys see how your service, electrical service, is going to look like? Very, very important. So, because that's the most important thing for us. So I focus on the electrical service. So here's my power coming in, all the 3 phases, and I'm bringing my power in, and then I'm tapping these conductor in, out, and for each one of them, right? Can you guys see that? In every meter and out. And then same thing here, in and out, and the same thing here, in and out. For disconnect, this is CT cabinet, and the same thing from here and out. Right? Do we have, how many disconnects do we have? 6 disconnects? 1, 2, 3, 4, 5, 6 group in one location. Did we meet the code? Yep, 6 disconnect. This is probably one of the most important things. It shows you how your service is going to be set. How many of you guys have seen these all the time? If you go to strip malls, typical. Right? Very typical. Now, I know, Brian, my friend, you asked about this. This is a weird, not weird, a special case where they have another box. This is where your CT cabinet is going to be, and this is your meter. Why would you do a CT cabinet and meter? Because we have a 400 amp. 400 amp and higher, you can't have just a meter and you stick the wire right through the meter. You have to have a CT cabinet. So what you do is you bring phase A and you put in a donut. Here's phase A. I'm just showing one phase, and you take the wires from it and you bring it to the meter. 2 wires and bring it to the meter. That's your CT. You stick it right through the donut so you sense. So if you have a 400 amp here, this will be seen coming into the meter as 5 amps. Can somebody tell me if I have a 200 amp here, what do you think this will go proportionally? 2.5 amps. So whatever goes through the cable will reflect through the meter, right? That's what CD is. More amps in, more amps in the CT out, but no the max goes 5 amps. That's why they start with the max, 400 to 5. If this becomes 100, so 1/4, this will be, what's 1/4 of fifth? 125? 120, no, 1/4.
Oh,
So if you take 100, divide by 400, give you a fourth. So you need a fourth of fifth. A fourth times what did we say here? A fourth of 1.25. Thank you. 5 divided by 4, which is a fifth of 5. 1.25. Yeah, 1.25. Can you guys see how proportional the CT is? We'll talk more about CTs as we go into the commercial. Any question about the service? This is basically the best thing here that shows you the service that we care about. A nice picture of our service. Any question, guys? Any comments? How the service is coming? Can you visualize what the building is and what the service is? Cool. Okay, so that's my service. Let's go back to A5. A5 have different sections of the building, guys. They're giving different sections of the building, north elevation and south elevation. Same thing how it's going to look in the north and south. Brick vents here, so this shows you, I think there's some lights here. I think these are exterior lights. Can you guys see that here? I'm zooming right into this one. It's exterior lights. So they showed where the exterior lights going to be mounted. So if I want to know how high from the finished grade I need the exterior lights, you can go measure from here all the way and multiply by the scale, right? And the last one, these are cross sections. Anybody knows what's the difference between a cross section and a view? When you do architectural work, guys, there's a plan view. That's what you're working on. That's as if you cut the building this way and you have an image of the building so you can see all the doors and the windows, right? That's a plan view. Elevations, you're as if you're looking at the building from the outside, right? 4 elevation. Now sections, if I want to see, look at this hallway right here, behind this wall. If I want to see this hallway, can I get this one from an elevation here? No. Can I get it from a plan view? Yep, I can, but I need the height of the wall. So long story short, what they do is imagine cutting the building from the middle. Cut it and you look at it. They call them sections. Who cares? The big deal, guys, for the architects. Big deal. It shows more details, architectural building details for the builders, so they can build walls and ceiling and floors. Remember, we are in the business of building buildings, ultimately. So look at this section. Section AA can give you the stairway. Can you guys the details about the stairways, the heights and so forth? And section BB give you more details here and windows and so forth inside the drugstore. So anyway, so if they ask you foundations, the dimension of the foundation and so forth. So the sections are meant to give you more information, architectural building information about the building. Everything, like I said, Aaron, my friend, the E1 through E4 is what you're going to spend on 90% of your time. 10% of your time is going to be on A1 through A6. Only when you become really a project manager. If you're a project manager and estimator, looking at the architectural and the mechanical drawing becomes a must. And you're going to see, we're not going to look at the details. There's no way you can look at the details. So you're going to look at the big picture. Because ultimately, making foundation sections and all stuff, we have an architectural program that does that for a living. All what they do is they just build buildings, cut them. We are electrical. We take the building, we install electrical system in it. Cool? Any comments, any questions, guys, about that? So that's what the blueprints. We will be referring to each one of them as we go through the book, guys. So I can't emphasize, Adam, my friend, The book is good. It's a good book. It walks you through a commercial project. It correlates with the project that we have, different ideas of doing things. So if you have a strip mall and somebody say you design a system, come up with a design for this strip mall. What comes to your mind? This is exactly this building that we did. Okay. So that's basically what I wanted to walk you guys through. And again, start with the beginning and end. Start with the beginning in mind. That's it. That's what you guys are gonna be doing. A power system for 5 tenants and the owner. Any comments, any questions for Chad? Brian, makes sense for the most part? No, yes. Okay. So please grab your books, guys, and do it. I'm gonna give you, okay, I'm gonna give you a quick break here, a long break, and then I'm gonna go over Microsoft project, just show you how to start. Do you guys mind? But maybe we'll give you half an hour or so. Okay? Cool? Thank you.